You've heard that sound in footage from every American conflict of the last 100 years. A slow, deliberate, mechanical thumping. Not the rapid chatter of a rifle, not the sustained roar of a minigun. Something deeper, more deliberate. A rhythm that carries weight in every sense of the word. That sound is the M2 Browning. The Ma Deuce. The weapon that has been mounted on American tanks, aircraft, ships, helicopters, and ground vehicles since 1933. The weapon that was firing at Japanese aircraft at Pearl Harbor in 1941, at North Korean infantry in 1950, at North Vietnamese positions in 1968, at Iraqi armor in 1991, and at Taliban positions in Afghanistan in 2010. One weapon, nearly a century of continuous service. Through every technological revolution in military hardware, through the jet age, the nuclear age, the missile age, the digital age, while every other weapon in the American arsenal was replaced, upgraded, or made obsolete, the M2 Browning kept firing. But here's what almost nobody has been told about why. The M2 Browning's longevity is not primarily about the weapon itself, it is about the cartridge it fires. The 50 caliber Browning machine gun round. A cartridge designed in 1918 by John Moses Browning in Winchester. A round that has been in continuous production and continuous military service for over 100 years. A round that the United States military has tried to improve upon, replace, and surpass, and that has defeated every attempt. The reason the M2 Browning is still firing the same bullet it fired in 1918 is not that nobody tried to find something better. It is that the physics of what that cartridge does and the engineering trade-offs required to do it have proven so well optimized that a century of subsequent development has not produced a combination of size, weight, energy, and versatility that meaningfully surpasses it. So, what exactly makes the 50 caliber Browning machine gun cartridge so difficult to improve upon after 100 years? Why did General Pershing's request for a heavy machine gun cartridge in 1917 produce a round that would still be the standard a century later? What specific physical properties of the 50 caliber make it the optimal solution for the range of missions the M2 Browning performs? Why has the M2 been successfully adapted to aircraft, ground vehicles, ships, and infantry use when most weapons are optimized for a single platform? Why does the M2A1, the current production variant, differ from the original M2 in only a handful of specific ways after 90 years of development? And why, when the United States military has spent billions of dollars developing next-generation weapon systems, does the Ma Deuce keep showing up on the latest generation of armored vehicles, helicopters, and naval vessels? Here's the one fact that should reframe everything. According to the SDI website, the M2 is the longest-serving weapon in the US military and is in use by nearly 100 nations. According to Military Times, roughly 50,000 Browning M2 machine guns remain in use by the American military today. A weapon designed in 1918 is currently deployed in 50,000 copies across the most technologically advanced military in human history. The question is not why the M2 has lasted this long. The question is what Browning got so right in 1918 that 100 years of subsequent engineering has not been able to improve upon it. Most people assume the M2 Browning's longevity is a product of the same institutional conservatism that kept the M1911 in service for 74 years. The military likes what it knows. The logistics of transition are expensive. The training burden of a new system is significant. The M2 stays not because it is genuinely the best solution, but because replacing it is more trouble than it is worth. That assumption is wrong in a way that the engineering record makes clear. The United States military has replaced virtually every other weapon system from the World War II era. The M1 Garand gave way to the M14, which gave way to the M16, which gave way to the M4. The M1 Abrams replaced the M60 tank. The F-86 gave way to the F-100, which gave way through multiple generations to the F-35. The Navy has retired and replaced entire classes of ships. The military has demonstrated repeatedly that it is willing to absorb the cost and disruption of replacing systems when a genuine improvement is available. The M2 Browning has not been replaced because no genuine improvement has been available, not for lack of trying. The military has evaluated alternatives. Programs have been funded, competitors have been tested. The 50BMG cartridge and the M2 platform have consistently proven to be the optimal solution for the specific combination of range, energy, versatility, and reliability that the heavy machine gun mission requires. Do you enjoy watching our videos? We would love to know in the comments. We put a lot of effort into our videos and make them absolutely free, but producing them is not free. If you have gotten value from this channel and want to help keep daily uploads going, buying us a coffee through the link below makes a real difference. Every generous contribution goes back into the channel, making improvements to our videos and keeping daily uploads possible. Thank you for the support. Now back to the video. Here's what John Moses Browning designed in 1918 and why it has proven so difficult to improve upon. The origin of the M2 and its cartridge is documented by both the SDI website and Military Times. The story starts with General Pershing in World War I, who immediately recognized that the US lacked a heavy machine gun and a cartridge suitable for use against Triple Alliance aircraft, and yet to be developed tanks. The Army passed the memo to the one person who could deliver, the hero of American gun design, John Browning. Never one to pound sand on novel designs when older ones would suit just as well, Browning quickly scaled up his M1917 30 caliber machine gun. It took him, Winchester, and Colt less than 1 year to develop the new cartridge and a complete working prototype. Despite the incredible development speed, the machine gun debuted just too late for the Great War. The 10,000 ordered by the US military were never utilized. The .50 BMG cartridge that Browning and Winchester developed is a 12.7 by 99mm round. The cartridge was as significant a development as the machine gun itself. According to some, including the American Rifleman, it was influenced by Germany's 13.2 by 92mm SR, but this is debatable because the American cartridge's development appears to have begun before the discovery of the German round. Regardless, the rimless .50 BMG has excellent, similar terminal ballistics, and it could penetrate 0.9 inches of face-hardened steel plate at 200 yards. The physical properties that make the 50 BMG so difficult to improve upon are a function of the relationship between projectile mass, velocity, and the energy required to achieve both. The 50 BMG fires a bullet of approximately 647 to 800 grains, depending on the specific loading, at approximately 2,900 feet per second. The resulting muzzle energy is approximately 13,000 foot-pounds. That combination of mass and velocity produces a round that is effective against light armor, aircraft, crew-served weapons, vehicles, and personnel at ranges exceeding 1,800 meters. The critical insight is that the 50 BMG sits at a specific point in the spectrum of military cartridges that is genuinely difficult to improve upon without crossing into a different category of weapon entirely. Below the 50 BMG, rifle caliber rounds, 5.56mm and 7.62mm, lack the energy to defeat light armor and crew-served weapons at extended ranges reliably. Above the 50 BMG, 20mm and larger autocannon rounds require significantly heavier and more complex weapon systems that cannot be mounted on the same range of platforms. The 50 BMG occupies the gap between rifle caliber and autocannon with a combination of energy, range, and platform versatility that no subsequent cartridge has matched. It is heavy enough to defeat light armor and aircraft at combat ranges. It is light enough to be fired from a weapon that can be mounted on a vehicle, a helicopter, a ship, or a ground mount. It is accurate enough at extended ranges to engage crew-served weapons and vehicles. And it is versatile enough to accept a wide range of projectile types, including ball, armor-piercing, incendiary, tracer and armor-piercing incendiary, which extend its effectiveness across a wide range of targets. As the SDI website documents, unlike smaller calibers like .30-06, it has a large enough projectile to carry a wide variety of ordnance and material, like high explosive, incendiary, or large hardened penetrators. This projectile versatility is a direct function of the cartridge's physical size. A smaller cartridge simply does not have the volume to accommodate the range of projectile types that the 50 BMG can carry. The cartridge's size is not a limitation. It is the source of its versatility. According to the SDI website, the M2 Browning's operating system is as significant as its cartridge. It is a short recoil-operated, belt-fed machine gun that fires from a closed bolt. Upon firing, the barrel itself reciprocates a short distance, imparting momentum to the bolt and bolt carrier. The bolt unlocks and continues to the rear, ejects the case downward, and extracts a new cartridge from the belt. As the bolt reaches its full rearward travel, the driving spring and compressed buffer discs push it forward, chambering the new cartridge and advancing the belt. The operating sequence is simple and robust. The gun operates at about 450 to 600 rounds per minute, while aircraft variants ANM2 and ANM3 are significantly faster, up to 1,300 rounds per minute. The relatively slow cyclic rate of the ground variant is not a limitation. It is a feature. A slower cyclic rate means lower heat generation per unit time, longer barrel life, and more controllable ammunition consumption. The M2's rate of fire is optimized for sustained fire rather than maximum instantaneous firepower, a deliberate design choice that contributes to the weapon's reliability and longevity in sustained operations. The M2 also provides a semi-automatic setting, which, combined with closed bolt operation, allows for outstanding accuracy. Gunnery Sergeant Carlos Hathcock used a customized M2 HB to make the longest confirmed kill in history while deployed to Vietnam in 1967. That shot was 2,500 yards, and the record stood for 35 years. A machine gun used as a precision sniper platform with a scope mounted on the barrel is a testament to the accuracy potential of the closed bolt operating system that Browning designed. Improvements to the M2 over its century of service are documented by both sources. The SDI website records that, while prior to World War II, the M1921 was improved by a Springfield Armory engineer, Dr. Samuel Green. He reconfigured the charging handle so it cams downward before travel, giving the user a mechanical advantage and requiring much less force to compress the massive recoil spring. Green also gave the machine gun the ability to be belt-fed from the right or left without significant time or special parts. The SDI website also notes that, as time progressed, the receiver was developed to be universal and usable with a water-cooled or air-cooled barrel. By 1933, these changes made the guns much more flexible for different services, whether water-cooled, heavy-barreled mounts or light-barreled aircraft versions with a higher rate of fire, such as the ANM2. Today, Military Times reports the United States is replacing the M2 with the M2A1. Though the basics are little changed, the newer model has the added advantage of a genuinely quick-change barrel, which, unlike its predecessor, does not have to be timed and head-spaced after each barrel exchange. A new flash suppressor was also added, and it reportedly reduced the prodigious muzzle flash by 95%. The headspace and timing requirement of the original M2 was one of the weapon's most significant operational limitations. For most variants of the M2, headspace and timing must be set after assembly and before use. In the M2, headspace is the distance between the face of the bolt and the rear of the barrel, and it is adjusted by rotating the barrel. Timing is set, so firing occurs when the recoiling parts are in the correct position. Improperly set headspace or timing can damage the weapon system or injure the operator. The M2A1's quick change barrel eliminates that requirement. That is a genuine operational improvement. It reduces the training burden and lowers the risk of operator error. But the fundamental operating system, the cartridge, and the basic mechanical architecture remain unchanged from what Browning designed in 1918. Through the 1930s, the Navy and the Navy Air Service made extensive use of the design, particularly in aircraft. The AN-M2 was an excellent compromise between the heft and lower velocity of autocannon and the weakness of rifle-caliber machine guns. The P-47 could carry up to 8 AN-M2 in its wings, and bombers like the B-17 were positively bristling with them. From half-tracks to heavy tanks, M2s were mounted on anything on the ground that could carry them. As Military Times documents, in 1941, as Japanese planes strafed American battleships at Pearl Harbor, it was an M2 Browning machine gun that messman second class Dory Miller wielded to defend the USS West Virginia, earning him a Navy Cross, the first Black American service member to receive the award. As Audie Murphy mounted his tank on January 26, 1945, near Holtzwihr, France, he used a .50 caliber machine gun to hold off advancing German troops in one of the war's most famous stands. Here is what the M2 Browning's specifications mean in actual operational terms. The M2HB, the heavy-barreled ground variant, weighs approximately 84 pounds without its mount. The weapon is 65.1 inches long. The barrel alone weighs approximately 24 pounds and is 45 inches long. The weapon fires the .50 BMG at a cyclic rate of 450 to 600 rounds per minute from the ground variant. As Military Times documents, roughly 50,000 Browning M2 machine guns remain in use by the American military today. The weapon is in service with nearly 100 nations worldwide. The total number of M2 Brownings produced since 1933 exceeds 3 million, making it one of the most widely produced crew-served weapons in history. The .50 BMG cartridge generates approximately 13,000 foot-pounds of muzzle energy. For context, the 7.62 by 51mm NATO round, the standard rifle cartridge used in the M240 machine gun, generates approximately 2,600 foot-pounds. The .50 BMG generates 5 times the energy of the standard rifle-caliber machine gun round. That energy differential is what allows the M2 to engage targets, light armor, aircraft, and crew-served weapons that rifle-caliber weapons cannot reliably defeat. The effective range of the M2 against area targets is approximately 1,800 meters. Against point targets, vehicles, and crew-served weapons, the effective range is approximately 1,500 meters. The maximum range of the .50 BMG is approximately 7,400 meters. At maximum range, the round retains enough energy to be dangerous, which is why the M2's firing range safety requirements specify a danger area extending to that distance. The M2 Browning's development from the original M1921 to the current M2. A1 spans a century of incremental improvement without a fundamental redesign. This development history is unique among military weapon systems. According to the SDI website, only a few of the original M1921 models were put into production in a water-cooled anti-aircraft configuration for use by the US Coast Guard. The machine gun's basic design has not changed since then. The water-cooled configuration gave way to the air-cooled heavy barrel of the M2HB, the variant that became the standard ground weapon, as the Army recognized that the weight and complexity of the water cooling system were unnecessary, given the M2's relatively slow cyclic rate and the thermal mass of its heavy barrel. Military Times documents that the advent of World War II firmly cemented the M2 as America's heavy machine gun. Equipped on both American bombers and fighters, the M2 provided a lethal wall of lead for its plane crews. By the end of World War II, more than 2 million M2 machine guns had been produced in a variety of configurations. After the war, the SDI website notes that the M2's use in aircraft began to be phased out as weapons, like the 20mm rotary cannon and air-to-air rockets replaced them. But the M2 remained mounted on ground vehicles, ships, and boats. The transition from aircraft to ground and naval use reflected a changing threat environment. Jet aircraft required higher rates of fire than the M2 could provide, yet ground vehicles and naval vessels continued to face the same range of threats that the M2 had always addressed effectively. As Military Times documents, the machine gun has come up for re-evaluation, and at least 4 major attempts have been made to develop a lighter gun with less recoil, with only one making it past field tests. Even in that instance, the weapon was only in the field for a brief time before it was replaced by the old M2. The replacement attempts failed not because the army was unwilling to change, but because the alternatives could not match the M2's combination of reliability, versatility, and terminal effectiveness across the full range of missions the weapon performs. You've been surrounded by the engineering principles of the M2 Browning and its cartridge your entire life without recognizing it. The 50 BMG's position in the spectrum between rifle caliber and autocannon, too powerful for rifle use, too light for autocannon, is the same engineering sweet spot as the medium-duty pickup truck in the automotive market. A compact car is too small for heavy hauling. A semi-truck is too large for everyday use. The medium-duty pickup occupies the gap between those two categories with a combination of capability and practicality that neither extreme can match. The 50 BMG and the medium-duty pickup are both optimal solutions to the same engineering problem, finding the point in a performance spectrum where versatility and capability intersect most effectively. The M2's slow cyclic rate, 450 to 600 rounds per minute, compared to the 6,000 rounds per minute of a minigun, is the same engineering trade-off as the difference between a precision lathe and a high-speed production machine. The precision lathe operates slowly and produces accurate, consistent results. The high-speed production machine operates quickly and produces high volume. The M2's slow rate of fire produces accurate, sustained fire with manageable heat generation and ammunition consumption. The minigun produces maximum instantaneous firepower at the cost of enormous ammunition consumption and heat generation. Both are correct for their intended missions. The quick-change barrel of the M2A1 is the most significant improvement in the weapon's recent history. It is the same engineering principle as the replaceable blade system on a professional chef's knife. The blade is the consumable component that degrades with use. The handle and mechanism are the durable components that outlast many blades. The M2A1 quick-change barrel allows the consumable component of the barrel, which degrades from heat and wear, to be replaced rapidly without affecting the durable components. The chef's knife and the M2A1 are solving the same maintenance engineering problem with the same modular replacement solution. The 50 BMG's versatility, its ability to accept ball, armor-piercing, incendiary, tracer, and armor-piercing incendiary projectiles in the same cartridge case, is the same platform versatility as the modular smartphone. The smartphone's hardware platform accepts a wide range of software applications that extend its functionality beyond its basic design. The 50 BMG's cartridge case accepts a wide range of projectile types that extend the weapon's effectiveness beyond its basic design. Both are platforms optimized for versatility rather than single-purpose performance. The M2's closed bolt operation, which allows semi-automatic fire and contributes to the accuracy that made Carlos Hathcock's 2,500-yard shot possible, is the same precision principle as the single-shot mode on a professional camera. A camera in single-shot mode fires one frame per shutter press, allowing the photographer to control exactly when the shutter opens. The M2's semi-automatic mode fires one round per trigger press, allowing the gunner to control exactly when each round fires. Both systems sacrifice the rate of output for the precision of timing. The headspace and timing requirement of the original M2, the need to set the distance between the bolt face and the barrel after each barrel change, is the same precision calibration requirement as the valve clearance adjustment on a high-performance engine. Both require the operator to set a specific mechanical clearance to a precise specification before the system will function correctly, and both create a maintenance burden that can result in catastrophic failure if performed incorrectly. The M2A1's elimination of the headspace and timing requirement is the same engineering improvement as the hydraulic valve lifter that eliminated manual valve adjustment from automotive engines. Now for the honest part, because both sources are clear about it, the M2 Browning's weight is a genuine operational limitation. At 84 pounds for the weapon alone, before the mount, the ammunition, and the vehicle or aircraft required to carry it, the M2 is not a weapon that dismounted infantry can carry and employ effectively. The weapon requires a vehicle, a helicopter, a ship, or a fixed mount. This limits its utility in environments where dismounted infantry operations are the primary mode of combat, such as jungle warfare, urban warfare, and mountain warfare. In those environments, the M2's weight makes it a support weapon rather than a primary infantry weapon. As Military Times documents, at least 4 major attempts have been made to develop a lighter gun with less recoil. The weight problem has been recognized for decades. The attempts to solve it have consistently failed to produce a weapon that matches the M2's terminal effectiveness at the M2's range while achieving a meaningful weight reduction. The physics of the 50 BMG cartridge, the mass and velocity required to achieve its terminal effectiveness, imposes a minimum weapon weight that lighter materials and designs have not been able to significantly reduce. The M2's ammunition consumption rate, even at its relatively slow cyclic rate of 450 to 600 rounds per minute, creates a significant logistics burden. A sustained engagement can consume hundreds of rounds per minute. Each round weighs approximately 1.7 ounces. 1,000 rounds, which is less than 2 minutes of sustained fire at 600 rounds per minute, weighs approximately 106 pounds. The ammunition logistics required to sustain M2 fire in a prolonged engagement are a genuine operational constraint that shapes how the weapon is employed. So here's where you actually land. You came in hearing that slow, deliberate thumping and thinking about a weapon that has lasted a long time. What you now understand is why it has lasted. Not institutional conservatism, not resistance to change. Physics. John Moses Browning and Winchester designed a cartridge in 1918 that occupies a specific point in the spectrum of military projectiles between rifle caliber and autocannon, where the combination of energy, range, versatility, and platform compatibility has proven optimal for the heavy machine gun mission. The 50 BMG is heavy enough to defeat light armor and aircraft at combat ranges, light enough to be mounted on vehicles, helicopters, and ships, accurate enough for precision engagement at extended ranges, and versatile enough to accept a range of projectile types that extend its effectiveness across a wide range of targets. Every attempt to improve upon that combination has failed to produce a meaningful advance. The weapon that fires it, the M2 Browning, has been incrementally improved over 90 years of service. The quick-change barrel of the M2A1 is a genuine operational improvement. The flash suppressor that reduces muzzle flash by 95% is a genuine tactical improvement. But the fundamental operating system, the cartridge, and the basic mechanical architecture remain what Browning designed in 1918. As the SDI website documents, the M2 is the longest-serving weapon in the US military and is in use by nearly 100 nations. As Military Times documents, roughly 50,000 M2 Brownings remain in use by the American military today. That slow, deliberate thumping you hear in the footage is not the sound of a weapon that nobody bothered to replace. It is the sound of a cartridge and a weapon system that a century of subsequent engineering has not been able to improve upon in any way that matters on the battlefield. It is the sound of John Moses Browning getting the physics right in 1918, and nobody has been able to do it better. And if you think the M2 Browning's 100 years of service is the most remarkable longevity story in American military hardware, wait until you hear about the aircraft that has been flying since 1952 and that the Air Force says will still be flying in 2050. A bomber designed when Dwight Eisenhower was president, built while the Korean War was still being fought, continuously upgraded and modernized, and considered irreplaceable by the most advanced Air Force in the world, for a mission no later aircraft has been designed to perform as effectively. The engineering reason why a 90-year-old airframe remains the backbone of American strategic bombing is one of the most counterintuitive stories in the history of military aviation.